This is Randall Root. In this video we're going to take a closer look at how fact tables and dimension tables are designed. In a typical fact table, you would go through and define your measures. So, for example, I have defined a measure of sales quantity and actual sales price. These are two things I wish to report against. Now, to describe an actual sales price, I need a sales price of what? It was a sales price of a particular title. But more specifically, it may be that that book sells for a different price on a different day. So, in addition to being the sales price for the title, it would also be the sales price for that particular day. Heck, it could be on that particular same day, but a different employee gave a different price, so that would also be by employee. And for that matter, a different store could actually have a different price as well, so we'd have to include by store. It may be odd, but a particular sales ID or even an individual line item could have a different price. As such, the full definition of what the actual price was for a given title, on a given line item, on a given sale, on a given date, by a given employee, and on a given store. So, that being the case, that would define the description of my measure. Now, the same thing is true of sales quantity. And since both of them have the same descriptors, that being that the sales ID, line item ID, the date, the titles, the employee, and the store form the same description, it also means that they can be in the same fact table. The granularity of sales quantity is no lower than the particular date. Or in this case, if I've chosen the date time data type, I could actually have time as well. So for a given hour, or a given minute, or a given second. SQL Server's date time data type goes all the way down to milliseconds. So the fact of the matter is, I could have 2 days, the exact same date, same hour, same minute, same second, and even, well, actually I'd have to change the milliseconds, but even if I was off by a millisecond, the number would be different, and I'd have a unique value here, and the sales price or sales quantity would be associated with it. Now, I'm not entirely convinced that that would be appropriate, but I think you get the idea that the granularity has to do with how fine a detail something goes down to. In the case of something like a title ID, it's extremely simple. It's the individual title ID, or the individual employee ID, or the individual store ID. Those are all very simple. The sales date represents something a little bit more fluid in that we have to make sure that we define the particular granularity of that date. Other ones that have more individualized ID or scalar values, single values, like the sales ID has a single value, or the line ID has a single value instead of the date, which represents a range of possible values. But whatever the case may be, the fact is that in a fact table, you would go ahead and define measures that had the same granularity. How fine a detail these values. Granularity could be confusing, so let me explain. Let me try another approach. Let's have a sales quantity for all these different items of 15. So I sold 15 to a particular store by a particular employee for a particular title on a particular time and date for a certain sales line item and sales ID. Now, if I were to go ahead and take out, let's say I take out the date, that should make it an easy description, then what would happen is that the date would no longer be involved without calculation, and that would mean I'd have to change the sales quantity, not from 15, but to whatever the total was, regardless of the date. So regardless of the date, for a given store, employee title, sales ID, and sales, if there were three instances where the sales ID, the line item were exactly the same, the title was exactly the same, the employee was exactly the same, and the store is exactly the same, I'd have to add them up into a single unit value. Now, because the sales ID and the line item ID are pretty unique, not only pretty unique, they should be very unique, then I need to take out a few more things to express the grain even further. So let's say I take out the top three columns here. Sales ID is no more, line item is no more, and sales date is no more. Now the sales quantity would only reflect the total based on titles, employee, and store. So, regardless of the individual ID for the sales, line item, or date, what was the total for all titles over all time? All for that one employee and for that one store. Individual title, individual employee, individual store, what was the total of sales quantity for that combination? That is the grain. So by adding or removing columns or key columns, these are also referred to as dimensional keys or attributes. By adding or removing these, you can change the granularity. Here's something maybe that will help a little bit. Let's say that I go through at my fact table has states and store information. Now, if I go through and I do what we did previously, I have the state ID and wait a second, the state ID wasn't there previously. That's been added. So, what changes when you add the state ID to the fact table and just leave out or leave out, like we saw before, the state ID? Well, the way it works is that since the stores has a link to the states, then we could either just go ahead and make a fact table with the store ID, and we could always get the state information for our reports. We wouldn't necessarily have to take the state ID and put it right in the fact table. But does it hurt? Well, it turns out that an individual store can only be in one state at a time. And because of that, the relationship is that one store can be in one state, but one state won't, one store will have one state, but one store will have, I'm getting confused now. One state may have many stores, but one store will have only a single state. So it's a one-to-many relationship. In that particular case, because of the way the relationship flows from stores to state, and because there's only a one store to one state relationship, one-to-one, it makes no difference whether or not you put the state ID in here. It doesn't change the grain. Some people would say that it makes it a little bit report because you can report directly the state for that particular sales quantity. But in truth, I can still get to the state right through the store ID. And as far as I'm concerned, it makes it somewhat simpler to go ahead and leave the store ID as a gateway to the states in a data warehouse. Either way would work. However, what if we went ahead and took out the store ID and just put the state ID? That would not work. The reason for that is the granularity would change. In other words, let's say there were 3 stores in the state of Washington. The sales quantity would have to be added up for all the stores in the state of Washington. So this would not work. While it's true that adding in the state ID doesn't change the grain for the store because there is a one-to-one relationship between a store, one store can have only one state. But when you go the other way, such as just putting in the state only, it changes the granularity. If you meant to do that, that's fine. We'll just not be able to report on individual stores that way. But if you did it by mistake, obviously you've made a mistake. It's just as simple as that. Hopefully that makes sense about how grain works. So your typical fact table would probably look something like the one in the middle, where it'd have the sales ID, the sales line item, the sales date, the title ID, the employee ID, and the store ID. And I would go ahead and just leave out ID because I can always get through it. The dim states table. If you do decide to go ahead and design it, state ID, let's take a look at a typical dimensional table. In a typical dimension table, you would typically see the word dim in front. The dimension or dim distinction just defines its usage, much like fact sales that we just looked at. As far as the columns items that would go over, I have like title ID would come over, and title name would come over, and standard retail price, I might bring that right over, title category. It may well be that somebody just has something like name over in titles. And then when you get it over to the dimension table, I recommend you go ahead and put on an additional identifier. I mean, name is too generic. It's the name of what? It's the name of the title. The same thing might be true of standard retail price. You might just have standard retail price there, but want to upgrade it to title standard retail price. Notice that I put title in front of everything as a distinction between the ID and the name, the standard retail price, and the category. And I put it in front instead of saying category title or a name title or whatever, and I keep it consistent. Data type issues, you want to keep them as simple as possible too. Integer is fine. When I bring it over, integer works as great. When I take a look at this instance, so this is Unicode variable character 50, that works fine too. But when it comes down to money, is a unique type to SQL Server. It doesn't exist in a lot of other applications. Since the purpose of the data warehouse is to have applications write reports against it, I recommend going through and simplifying things by putting in well-known data types. Money is not a well-known data type, but decimal is. So by converting the money data type into decimal, you've actually just simplified the way clients see the data warehouse tables. In the original database, I had varchar instead of nvarchar. But if you look in the other tables of the database, you'll find that Unicode or nvarchar is being used in most places. Perhaps this was a mistake, perhaps it was on purpose, but the fact of the matter is that you probably should make things more consistent. So I would go ahead and put nvarchar over there, even if it started off as varchar. Sometimes you'll see things like somebody will have 35, or they'll have items like, 27 as far as different number of characters that are possibly supported. Once again, for the rules of simplification, I strongly recommend you just go ahead and put in simple numbers types. So instead of being like 17 or 27 or 35 or whatever it is, put in 50 or 100 or 200 or 500. When you're dealing with variable characters such as nvarchar or varchar, it has very little to no impact on the size of the table by specifying the larger size. And having simple, more consistent sizes, like you can pretty much assume everything's going to be 50 characters or 100 characters. It's not going to be 14, 15 different possible sizes for just varchar alone. It just makes things go a lot easier when people are writing at a later point in time. So just simple things like using name conventions, changing the columns so that they are consistent, data types so that they're more consistent to, or more standard to applications in the outside world, And changing the numbers around like 50 instead of 27, 35, just so that they're more standardized. All these things can really help to make your data warehouse a little bit easier to work with, a little bit more professional. In this video, we took a look at fact tables and dimension tables and kind of examined some of the things to watch for when you're designing both of these items. Hope you found it useful, and we'll take a look in the next video about the different design philosophies around star and snowflake tables. Until then, I'll talk to you later.